Jo. Aha.
I connect to my laptop to you?
Yeah, you can connect it with VGI. We have HDMI and this.
Alright,
board,
enough.
yeah.
There's enough. You have a clicker, right?
Oh,
Excuse me, what presentation do you have?
The over. I have time, not now.
Yeah, okay,
Just
so
checking
yeah.
if I have everything I need here.
yeah. Začneme takto. Musíme ho najít, no. Snad.
This is the right one.
Yeah, this is the right one. Yeah.
No normálně prostě stačí tady překliknout počítač 1.
Oh, jo.
A pohnout myší možná ne.
Dobrý.
Jenom to trvalo. Jo, stejně je tam program jako tak, místo smart, ten nejvyšší.
Jo, to je možná lepší, no. Tak jo,
Je tam
počítač
čas,
1,
je
jo?
tam ten,
Aha.
a možná teda, kam tady.
Počítač 1 tady dáme, jo, jasně. To naopak. Ale
Chceme vyměnit.
super. Yeah, it is.
This is one
Yeah,
of five.
yeah.
Hi, you are here about the talk about Kubernetes.
Kubernetes, yes.
Yeah,
okay,
welcome.
great.
Yes. This is me. I hook in and I'm good.
Are you going to have a demo?
Yes.
Okay.
It's video recorded though.
Yes. I hope that it's.
Well, so I'm
You
debating
need
whether
sound.
to do this. Ow, no, I'm not doing it. The video has audio with it, but I may just provide the audio as I go.
Maybe it works. We can try it. Yeah. We just ask you for the slides, please.
Oh, you need them on a key. Okay.
Yeah, thank you.
How would you want to get introduced?
Just Mike McGrath, senior principal architect.
All right.
Okay. And you are working on Project Atomic, or
I am, yes.
okay?
Hello everyone, this is D105 and we will start with Kubernetes presentation in 2 minutes.
Já jsem vám to materiál dnes, protože mám jenom 2000 a měl jsem 30 korun na 2000 a oni nemají drfů.
A kde to má?
Ten máš v tom Ečku za 30 korun.
Aha.
Chceš ho uviesť?
Ne, klidně si ho uveďte.
On povedal, že on chce povedať nejakú pozíciu a som povedal,
Ja
že
to
to robí
klidne
na
zvládnu.
atomiku.
Co?
Chceš ho uviesť teda?
Jo, klidně.
Dobre.
Já si asi podporu na tu Jen, jestli snad to nevím.
Yeah, I can.
Hey, Dennis, how are you? Good, how you doing? Doing all right? Trying to get my video set up here.
Yeah.
Use Fedora and then just work.
That's good.
I think it's 1024, the optimal resolution. Oh, this one. Yeah, that's an item resolution.
I've got more people helping me instead of just me. So you are sort of leading them.
Aha, my používáme tady tenhle, no? Nebo...
Ten je pohodlnější.
Aha.
Jak si to?
Do you prefer the bigger mic or this? Yeah.
Because you Říkáme, proč tam je 10 minut? Říkáme, proč tam je 10 minut?
Right, like, I'm not helping.
No. Maybe we can clone the screens. That will be the simple. Oh, you can just drag it here. I think it will work.
I'm going to try to swap
Yeah.
the sides and see if that helps.
Oh, great. Oh, it's a bit. Yeah, it's different resolution.
I'm just going to turn off the laptop screen.
Yeah, right. Right. So, hello everyone. Let me introduce the Mike McGrath, Senior Principal Architect, and this is the Kubernetes presentation.
Hello, everyone. Get my clicker out here. Running a little late, but I think we'll be able to get through everything. Just plug in and we'll get started. Okay, so just a quick sound check. Everybody in the back can hear me okay? I got some thumbs up back there. Hi, Ian. Thank you. So today I'm going to give a talk about Kubernetes, how it interacts with Docker, some of our plans for it, and I'll have some time for questions at the end, so feel free to save them until then, unless I'm saying something completely confusing to people. The basic agenda for the day is to just go over what Kubernetes is. I'll talk about some of the primitives that make up the Kubernetes orchestration. I'll talk about configuration and cluster setup, and then I'll give a quick demo. It's a recorded demo at the end where we can do some Q&A, but you can also see it in action. For those of you that have your laptops out, Kubernetes is in Fedora and ready to go, so you can yum install Kubernetes. It's there. I forget if Fedora 21 has good default configurations, but there are good default configurations where you can set everything up that we're about to show you just on your local host. You don't need a whole bunch of systems or anything. It works out pretty well. So Kubernetes is an orchestration system, and it's well suited towards horizontal. So this assuming that people know what Docker is and how it works. Just a quick show of hands, does anybody here not really get what Docker is and how it works? Okay, we've got a couple. So basically, for right now, just think of Docker as a little application container, something running inside of it can't get out. If that sounds a lot like virtualization, you can go ahead and think that for now. And when you get into it more, you'll kind of get a better understanding of the differences between virtualization and containerization. But for right now, conceptually, you can kind of think of them very similarly if you haven't gotten beyond that. And so in a Kubernetes environment, what you want to do is have your sort of master controller which I'll get into, and then it controls several other Docker containers and spins them up and moves them around, and that's what Kubernetes is. It also has a declarative language for launching these containers. And so the container inside of your application is an application component. It could be a database. It could be Apache or JBoss. It could be any pieces of your application that make it up. Or you could even take your container and kind of make this one large mud ball, I think, as Mark Little would have said it. If you really want to, you can do that. But Kubernetes will run much better if you can break all of your applications up into these individual components, these so-called microservices, and run them from there. So the Kubernetes primitives are, and I'm going to dive into each of these, but kind of get these defined in your head as we move forward, is the master, which is the primary controlling point of Kubernetes. You have a node. Previously it was called a minion. They changed the name. A pod is what lives on the minion. It's a little compute container, or it's a logical grouping of compute. The replication controller lives and kind of tracks what's going on inside of your application to make sure that it is matching what your declarative statement has said. The service then exposes that information to an end user, and then you have a label and a namespace. The label kind of gets attached to each of the pieces so that you can call them out by the API. And then the namespace goes into help defining what application namespace your application is living in so that it can't contact individual things that it's not supposed to contact, similar to the Linux kernel namespace. So if we're going back to the Kubernetes node, it's the system that is running your applications, and typically there are many of them. It was previously called a minion. And so if you have a Kubernetes cluster, this is, if you have hundreds of these things, 100 node system, the node itself is where your applications are typically going to be running. The Kubernetes master then controls and orchestrates those Kubernetes nodes. Now, just to kind of call this out, if you haven't worked with all this stuff before, Kubernetes isn't going to be spinning up and down nodes at this point. Basically, you as a system operator, it is your job to spin up and try to define how many of these nodes you need. You assign them, and then you basically let Kubernetes know that they exist, and then Kubernetes controls them at that point, and it will place Docker containers onto them or off of them. And so just kind of get it in your head as to where this orchestration is going to be taking place and what your responsibilities are. Again, Kubernetes is not going to be spinning up these virtual machines or physical machines even that are the nodes. You need to do that, but then once they exist, Kubernetes then controls them and owns that node and can control what goes onto and off of the node. So onto a pod. A pod is a single scheduled unit of compute, and it can contain one or more containers. It's been my experience that most people are liking to use one container per pod. And basically, as you create compute resources across several Kubernetes nodes, you can create them a pod at a time. So if you have a pod that has 3 containers of compute in it of some kind, let's just say that you've got Apache with a local memcached service, that could be a pod, those 2 individual containers. If you're going to replicate, you replicate that pod. And so each one of those nodes each one of those pods that gets replicated would contain your Apache service and your memcache service. And so looking at this diagram, you have a pod that's got the 2 containers, which each has the images, it has environment variables in it, and then the various file formats you have. These could be 2 or 6 in this case identical pods across several different nodes, and so that's what a pod looks like. So now we've kind of taken a very quick look at what the individual components are. Let's take a step back and kind of look at what this might look like installed in an entire environment, right? And so we'll start at the master. The master service has several different applications running on it, including where your network management is going to be. It's got the API server. etcd controls some of the information and metadata that flows in and out of the system. It's got a scheduler, and then your replication controllers are living there. Once you have your master set up, the next thing you would want to do is create a node. And so from the node, you'd have, in the node, you'd have your kubelet, which is another Kubernetes-specific daemon that runs on the node that then goes back and communicates with the master. You'd have a proxy service that allows the individual ports to be exposed. Obviously, Docker is going to be running there because this is where your Docker containers are going to be. And then you also have your network management, which I'm going to talk about later. Networking in Kubernetes is kind of basic or complex, depending on how you look at it. And then your storage management is going to be here too. Obviously, any applications that you have that have special storage needs, whether it's an NFS mount or something else, that happens on these nodes. And then, so once you get past your basic setup, you have a much larger setup where you have several minions and nodes. The minions all start out looking the same, but then depending on how you set up your environment, what applications you deploy, it changes a bit, right? So so just taking a look at this is kind of what most people are familiar with at the very high level when they read about Kubernetes, how it works, right? You have your master that you as an operator would log into and run commands or contact the API server and say, hey, I need new applications. And then obviously those applications get deployed onto the nodes. Moving on to some of the deeper level stuff that you need to watch and be aware of. The first one is the Replication Controller. And it sort of sits and keeps an eye on the system and attempts to make what you've defined, using this declarative YAML and language. It attempts to take the system that you've described and make it that way. And so your replication control you would be creating per service is what you look at. This is something that you need to create and deploy, which you'll see in the demo. And so you could say, I want to use this sort of pod template, these label selectors, and I need 5 of them. And you tell Kubernetes via the API service, here's my replication controller, and Kubernetes, the master, will then try to make that a reality. So if you needed your 5 Docker containers, you don't need to run some sort of Docker create command 5 times across several different nodes. You just tell Kubernetes, hey, I need 5 of them, and it will go out and do the rest. And so it has some sort of placement algorithm that it uses to figure out where to put them and just sort of handles that workflow for you. Services then define how those pods are consumed. And so, obviously you can create a Docker container and several Docker containers, but the assumption is that they're going to need to be able to talk to each other in some way, or that you will be able to talk to them even. And services are how you define this. And so you'd have your service port and your pod port. And for those of you that have used Docker, you'll be familiar with the mechanisms that Docker exposes the internal port. So you have your Docker container, say you have JBoss listening on port 8080. Nothing can get to that by default. You'd have to tell Docker, say, hey, I've got this container port 8080. I need it exposed on external port 8080. Do that mapping. And so you've got 2 ports at that point. One sort of on some sort of local host address that is not accessible. The next one on an external address on a service port. And the services are how you define this mapping between the two. Your label selector will then help define the label, and the labels are just a handy way of referencing them. Most of these things get some sort of UUID randomly generated and attached to them, so it's hard to contact them. And then you have, in addition to the different ports you have the internal and external IP, and then you could even have the external load balancer as defined, depending on what your needs are and how you want to set it up. So labels get attached to any Kubernetes object, and it names them so they can be identified and called via the API. And so if we look at this, I don't know how clear this looks. Yeah, it's not too bad. So this could be an example of a service that you're deploying, right? And so in the cloud in our top left-hand corner here is the actual service with an external service port. And this would be the IP address and port that your customers or end users would use to contact the service. And so once this is all set up, presumably that external port would get a DNS address of www.example.com or whatever, and it would then proxy these commands through to the actual pods. And then your internal service port then maps to these different pods. You can see that there's 3 individual pods that get mapped, and there's a label selector there as well. And via Kubernetes, this is also how you would start deploying and redeploying services. Obviously, once you have a service deployed, it is assumed at some point that you would like to change it, right? You wouldn't want to, you wouldn't want to deploy version 1, right? You've got version 2 you want to deploy, and it's via the service environment and a couple other commands you can run that will then allow you to deploy new containers and get rid of old containers. And in this example, you can see that we've defined the environment as a QA environment. We've got old versions and new versions, and the service point is pointing to them back and forth. So next up is namespaces in Kubernetes, and it helps define And namespaces get complicated because you've got Docker that has Docker namespaces like network namespacing and process namespacing. In Kubernetes, you have a similar mapping concept, and it's basically the Coke and Pepsi example that Tim gave earlier, where you want to make sure that you're going to be deploying a large multi-tenant environment. You want to make sure that application A is unaware of application B, and there may be some of you thinking, well, I don't host Coke and Pepsi, I just host my company's application. That level of scrutiny is not necessarily something I need. But another great part of this is with C groups and some of the other things that go in, making sure that you have this proper namespacing. Also make sure that application A doesn't fork bomb or go crazy and take down application B. And so that's the goal of having namespaces at all levels is, in a way, a method of protection for individual applications. Even if you're not worried about something malicious in intent, you can't necessarily protect yourself against bad lines of code or bad logic. But using these namespaces and things like C groups outside of the environment, outside of your application, you can help make sure that your applications are not going crazy and destroying other applications in unpredictable ways, right? So just a quick look at networking. So networking in Docker, depending on how you look at it, is either very simple or very complex. You can expose a port and bind to the port, and it's all very simple. You can get to it. The problem is that once you're inside of an environment like this, with the way Docker is set up today, there's really no protections that say the person A can't get to person B's port, or if there's a database listing there, you could have several requests coming from different applications from the same IP, because they're all sharing the same system. And so in that respect, it's very simple. The problem is when you want to go beyond that and set up VLANs at this application layer, it gets very complicated very quickly. And there's a couple of ways that there's several groups working to solve this problem now. One of the ones that we've looked at is Flannel, but the other ones that we're looking at more closely now are things like OVS. And again, that was mentioned in Tim's keynote. OVS looks very promising in this regard towards helping make sure that your applications are only contacting the services that they need to, making sure that it's not exposing databases to other applications that may not need it. But also making sure that there's this sort of logical underlying network infrastructure that exists and can be used and behaves the way you want it to, right? Because in an environment like this, your networking needs might be very complex. You may have a database that only certain application servers can get to, but you don't want, say, some group of memcache servers contacting your database for security reasons. And defining that logic and setting it up is fairly complex today, but there are people working on it. So let's take a look at how this might be set up. By default today, you've got 3 minions listed here. Each is listening on a 172 network. And we've got this Linux bridge with Docker on each of the nodes. So when you look up at this diagram and you see the minion, think of each of these as a virtual machine. Each of them has a few pods deployed. And inside of each of those pods, we have some containers that need to be connected through the network somehow. And so on each of them, we have a host IP in the 52 something address. And Docker is sitting on these machines and sort of mapping between the actual host network of the 52 dots and the individual pods, and it's exposing ports that way. And so the problem is, if we had, the problem is that, maybe the host we want to have on an administrative level, or perhaps there's several applications. This goes back to what I was talking about with making sure that your network topology matches what you want it to. And in this case, there really isn't much topology to speak of. It's all just a flat network on that 52.4 network. And so initially, especially in the Atomic group, we've been looking at Flannel, which is something you can just download and configure. It's fairly basic, and it provides much better network topologies than just this sort of flat 5.2 IP addresses that you were looking at. Okay, so with Flannel deployed, the minion setup does look a lot different, right? So inside of the pods, we've defined this 10 dot address space, and a network bridge with Flannel, you can see, also has the 10 dot. And so to go back to how this looked earlier, these were on these little loopback addresses. Now they're on actual publicly addressable space. The host IP hasn't changed in this case, But the way that pod 1 on one of the minions might talk to pod 1 on another minion, so say the 10.1.1.1 pod needs to talk to the 10.2.1 pod, it can actually address it as such, and the request will go from the container out through the system's firewall and be addressed even through VLAN tunnels, and then go on its way into the 10.1.2 address. And the idea here is that, presumably you'd have a 10.2 address somewhere on some other pod, and those two pods could live on the same minion, but their network spacing would be namespaced on the machine, but also then as it left the machine to go to their their destination addresses, wherever that might be. You want to keep those separate, and with Final you can accomplish that. So I've got a demo to show just how this all looks, but before I do that I want to stop. Are there any questions up to this point as to how Kubernetes works and or anything in particular you'd like me to address further? Okay. Okay, so I'm going to let this thing drive, and basically what we have here is a simple Kubernetes network config. Make sure I'm at the beginning here. Yeah. A lot of the commands are set up and already ready to go. And actually, let's just go back real quick. I want to show you exactly what we're going to be doing here. So we're going to set up a multi-tiered web application. We're going to show that the thing works. We're going to do a quick update. And the cheating in this demo is, one, it's been pre-recorded. I'm not going to be sitting up here typing it. But the clusters, the Kubernetes cluster is already set up. The containers have already been created at some point, and the Docker pull stuff has already happened. So I didn't explicitly spell that out, but when when Kubernetes goes and says you need to create an Apache Docker container on node 1 or whatever, it will say, hey, go out, and it'll do a Docker pull on that actual node. Docker will then download everything and go from there. And so it actually tells Docker to download. It's not doing any sort of magic where it's pushing the image over Kubernetes to the system, nothing like that. And so the Docker pulls have already happened on these machines, so they're cached there, which makes it all happen much faster, obviously, than trying to download it directly. And so behind the scenes, the basic infrastructure goes from top to bottom. We've got an external web tier through a web server to a read-only database layer. We've got our read-only databases. There's 3 of those. To a read-write database layer that you could interact with, to the actual read-write database service that's running. And so our, in this case, our master is running on 127.0.0.1 on port 4000. It's doing a quick put to create a new network of the 4 network. And we need to do this because we are going to be using Flannel in this case to set up the setup. The subnet is /24, which is what you would expect, and it's a VLAN. And so one thing about Kubernetes is the command line tools, and Kubernetes itself has only been around since June of last year. It has come a very long way during that time, but there are certain things that you might expect to see in the command line tools or elsewhere that don't exist yet. So A, it's a great opportunity to get involved because you can help shape that. But B, sometimes you just have to do things manually. So in this case, you can see that we've got our 4 minions, the 4 nodes. And if you look, we have no replication controllers defined. We've got a couple of services already defined. But first, we're going to create that read-write database layer. So at the bottom of that image that you'd seen, we're going to create that first read-write database pod. And the YAML file describes what that pod is going to look like. And basically what this does, it goes out to the Kubernetes master via the API. It says, hey, Kubernetes, I need to create these pods. And Kubernetes is going out and doing all of this. And then we have to create the service to then expose those pods, right? So it's a 2-step process. First, go create the pod that has the containers in it. Next, expose it so that the other applications in our service stack can properly function and access them. Next up, we're going to be creating this read-only database controller. If you remember, there were 3 of them, so we do that via a controller service, not via the pods. And then Kubernetes is going to go out and create 3 of those and then create the service for them. And so I'm going to stop it for a second. At this point, we have that individual, I'll go back to the diagram. At this point, we've created this bottom read-write database pod. We've created the service above it so it can be exposed. We created the replication controller for the 3 read-only databases, and now we've also created the service to expose though. So the bottom half of this whole diagram has already been, has just been done and created. Next, though, we need to expose it via this front end that is going to be contacting those slave databases. And in case you're curious, if you go to the GitHub website, all of these YAML files exist on the Kubernetes example. This is the guest book example. So if you want to go home and do these on your own, or you are tired of hearing my voice and want to do it on your own right now and you have your laptop, be my guest. And so, again, you create the front-end controller. There were 4 of those, and the service and exposes it. And so just with those commands, we've basically created everything we need to. And so the slave controller has created the 2 replica sets at this point. The guestbook PHP example has created 4 of them. You can see that, and you can also see the image names listed under here that have the actual Docker image locations that they were pulled from. And if we do get pods, you'll be able to see the pods listed there, running on various hosts. You can see their name. It's a bit cumbersome to go through and actually read, but this is what the Kubernetes command line tool looks like at this point. And you can see that they are all indeed running. Go through these. Okay, so now that everything is running, you can actually go through and get a dump of the YAML, because as you remember, we had created the host names that we have here listed in the 10 dot address. But if you remember from the very first command that we ran for Flannel, it created a 4 dot address. And if you get the master, you can actually see the 4 dot address being exposed via the actual YAML file that comes up. And so if we had a DNS entry or anything, it would go to that 4 dot address. Okay, so in the interest of time, I know that we have a lot of individual things here. I'm going to jump around real quick and show some of the real important parts of this. So you can see as we go directly to the host, we can pull up actual interfaces. Let's see if I can get to exactly the part that I'm looking for. Looking for the actual guestbook example functioning. So this is the actual guestbook that you can log into, type things in, it comes yes and no. These are the individual pods that it's going to, because remember, as you're sending information out, it's sending it to the, you need to send that information to the, that master database that had been up. You need it to replicate up. And so that's what the actual application does. And there is an example you can see in the slides where you want them all to go to individual. You want the actual command when you submit it just saves it to the database, right? So it's a very basic guestbook example where you put in your form, you click submit, and it replicates up. And so that's really all this example does. I really think that that's all the important pieces. So by my count, we've got about 5 minutes left. I'm happy to show more pieces of the demo. We got a little bit of a late start, but I don't want to cascade that through the rest of the day. So I want to real quick thanks Eric Paris for putting a lot of this together and putting the demo together. I know many of you had signed up originally to come see him. I'm happy to fill in. And so I'll stop here. Are there any questions? Yes? So the question is, how is storage handled by Kubernetes persistent storage? So the way that the storage works by default is it's just using local storage on the system. The larger question is, let's say you need to do a file share of some kind, either via NFS or a SAN. And Kubernetes, the pieces and fundamentals for that are being created still today. I have not actually seen any of that working yet. I know that there are people that are playing with it and getting things working, but it's still primitive enough that if you need something of that, you would probably need to set most of that up yourself today. So the question was basically, I think basically the question is what is inside those YAML files, and how do they get exposed? And well, we've got a little bit of time. Let me pull one of them up, and I'll show them to you. I'll actually pull up one that was being used. Just a second. So this is actually out on GitHub today, so you can pull this up yourself if you want. Under examples, guest book, and let's take a look at one of those Redis slaves. Let's see if it's listed here. Slave controller, slave service. So this is the slave controller. And you can see here on line 6 that it does list the actual number of replicas required, and you can go through and edit this as you need to define things like CPU. You can define where the ports are being bound, and so part of this file is actually describing what your Docker container has in it. So it's got some of the port mappings built into it. It knows what the image is going to be called. In this case, Brendan Burns Redis slave. You name it here. But really, it's really pretty basic. You go through and you can pretty easily see how you'd edit this to change for whatever replication that you have with it. But a lot of the things that are missing here are the scripts that may actually need to be run inside of the container. A lot of those you need to put together. Also, there are environment variables that you're going to need to be passing back and forth for things like your database password and that sort of stuff that you need to fit into the picture here. So, okay. Of course. Oh, and while we're on the topic, so this was the controller. Remember, the controller would actually go out and create the Docker containers. This is the Redis slave. This is the service that would then expose that. And so you can see the services are actually very, very simple. You need to name it. You need to define what the ports are. But Kubernetes will go out and do the rest. You're not defining IP addresses here or anything. Kubernetes is finding IP space available, defining that, and then exposing it. And so if you're going to move into an environment like this, you kind of have to be ready to give up some of the control that you may have been used to when trying to define these services. Kubernetes does a lot of that work for you, and will continue to do so, especially considering that it's only 8 months or so old at this point. As an operations guy, I'm very excited about it because you're going into these Docker containers and basically having these services that are defined and having a way to describe how they should be set up. Kubernetes will try to keep them in sync. So if a server goes down, it will notice and presumably try to spin up a new pod. It's a very different way of doing this sort of work. People are kind of used to doing this via maybe configuration management, where you try to define what the environment looks like. You run your configuration management, and it goes out to your system and makes all the changes for you. But then, if one of those systems dies or something, it doesn't necessarily try to auto-fix any of that stuff. Kubernetes really takes it a full other step towards automation and helps keep those replica sets defined. If you say you need 5, it's going to do its best to make sure that you have 5 of those pods out there. And it's an important distinction to make because it'll help you sleep through the night more, which is always good. So I think I've got time for one more question, and then we need to call it. So I don't know. What's the difference? And the question was, I said they use YAML, and this is JSON. And I think I've always used JSON. I've seen YAML files go in. Does anybody know? Does it take both? Somebody here. Maybe it takes both. I don't know. Kubernetes is magic. Anything is possible with Kubernetes. Yes, anything. So, and so with that, I'll call it. I will say that tomorrow there is going to be a workshop with this. If you want to bring your laptops, we'll help you get it set up. We're going to set it all up on your local workstation. We're going to see how that goes. It'll be very exciting, but we'll get you deploying your first app tomorrow if you can find it on the schedule. So thank you very much.